All right, so we're going to talk about two things this time, so it should be a pretty short video. Evaporative cooling and high specific heat. So evaporative cooling is when you have water, and we'll use humans as an example because it's an easy one, water on your skin and your body heat. Okay, so you have been working out or whatever, you're sweating, you're hot, so your body is actually hotter than normal. That heat is going to convert this water from a liquid to a gas, so it's going to cause evaporation of that water. And so that water is going to take that heat with it. So the heat that it absorbed to be converted from a liquid to a gas, when it flies off your body as a gas, it takes that heat with it. And so it cools you down that way. And so sweat is a good example of that. All right, so it is evaporation, but it is cooling you off. And so the name is pretty indicative of what's going on. So that's the goal, is to cool you off using evaporation. All right, high specific heat is that it requires a lot of energy to change the temperature of water up or down. So it takes a lot of energy added to make it warmer, or it takes a lot of energy removed to make it cooler. Compared to other liquids. So I know you think, oh, I can put a pot of water on the stove and turn it on and it boils. That's not a lot of energy. But compared to other liquids, it is a lot more energy. This is important for especially things that live around water. So if you think about the ocean, if you think about if you were comparing the change in temperature from night to day on land versus in the ocean, you're going to see a lot greater change on land because we don't have all the water. We do have a lot of water vapor, but not the ocean. So when you look at the ocean temperature and how much it changes, even from summer to winter, the ocean temperature does not change that much from winter to summer. It does change, but not as much compared to, say, on land in Colombia, we might be 25, 30 degrees in the winter and 100 in the summer. That's a 70-degree difference. But the ocean will never have that big of a difference in this area. We don't have enough exchange of heat. So when we see water, we see that it resists temperature changes really well. And so that's really good for things that live in there. Because you can imagine if you were a little fishy and the water went from 30 to 100, it wouldn't be really good for you. So things that live in the water are really glad that water doesn't change. So that's what high specific heat means, that it takes a lot of energy to change the temperature of water, or the loss of a lot of energy to make it cooler. And so water tends to hold its temperature a lot better than air. And that is that. So if you have any questions, let me know, but I hope that helps.